Alright, should be making a video, draft physics and such. Have some neuralgia trouble in my jaw, so a bit of pain. So yeah, I'll be angsting through the video. Anyway, I really didn't have a Dissident dumbass of the week prepared, so I figured I could find one easy enough in this Saturday chat. Franklin Who, Harry Rinker, I think, usually some guy, Bill Lucas, and then other people who don't speak very good English. So anyway, let's see what shows up in here. We'll just jump through it and just see if we get lucky. They went on a little extra, I see, so they must have gotten into some argument or something. So at this particular point, they're arguing about, apparently they have email conversations. None of these people make videos, unfortunately, in any independent way. So it's, I don't know, it's just kind of annoying that you can't find people who want to argue these points, you know, regarding how things work. So anyway, in some email conversation, they're arguing about the fact that electricity tends to travel very fast through wires, you know, approaching the speed of light. But the velocity of the electrons, the current, as described, travels much slower. And what they're really talking about is what they calculate as the drift velocity of the electrons, which isn't really the velocity of anything. It's just a calculated velocity that has to do with how many electron volts they're moving, and so they're counting them as electrons, actual electrons, when all it really is pressure. And so there really isn't any. It's the look, the voltage doesn't go one way and the current go another way. These are all just conventions used to make it work mathematically. But it's not how it really works. The current and the voltage both go the same way. It's a real positive force. Even when it's moving in the negative direction, so to speak. It's always a positive force moving from one point A to point B. And all of it moves in that direction. So drift velocity is not a real velocity of anything that matters. It's just a mathematical convention.
Traveling at sea, how does that, where does that charge, how does it get there? Because it can't travel at sea to keep up with the wave, so the wave would have to go faster than the charge that's producing it inside the water.
Right, so first he's using the word wave, which is nonsense, and you know, moving the speed of light, it's just, you know, well, whatever. There's a force. The electrons are moving the force essentially, but the atoms are essentially doing it in the sense the atoms are the things that have the electrons in them. Electrons pressurize. And all that's really doing is the electrons are pushing pressure into each other. They repel each other. One moves towards another one. That one moves away. That one moves away. That one moves away. That's all that's really happening.
That's really basically all it is. You follow that?
Clearly, and when current is alternating, the electrons never really drift anywhere. So if you're talking about an alternating current, then you really don't have to worry about it, because then you can understand that the current is constantly pushing this way, then it pushes back this way, then it pushes back this way. The electrons never go anywhere.
Okay, so how does that challenge the mainstream notion that electricity...
Well, the current in the wire can't go fast enough. I mean, that's pretty obvious.
Well, it's pretty obvious when they diagram it as going the wrong way that it really can't go fast enough when it's going the wrong way. So again, it just doesn't, you can't get too caught up in their conventions as being real things. They're just conventions.
Harry,
are you saying that it's a wave phenomenon, then really the thing that is traveling, the actual particles, let's say air, don't have to travel from point A to point B. The wave, we know, travels much faster, even though the particles themselves don't travel.
I mean, I hate to say that that's a better metaphor, but yeah, it's a better metaphor in the sense of understanding that molecules bang into each other and they're just sending a vibration in a direction. The vibration goes, but the things themselves only move a tiny bit.
It went off, right? So I think that would that be an adequate refutation of that argument? that what's
What
traveling
argument are we talking about?
violet waves.
Well, it's pretty simple, although the way I ever talk.
See, the smarter way to look at it is the thing gets big and it gets small, and it gets big and it gets small. So you can almost think of it that way, that it pressurizes. The atom goes positive, the atom gets a little bigger, the electron's orbit gets bigger, and then the one next to it is smaller. And the pressure ends up getting shared between the two. So what happens is the big one shares its pressure with the small one. The two of them even out. And if there's a smaller one over here, then these two even out. And all that's really happening is the size of them is changing. So nothing's really moving anywhere. Everything's just contracting and expanding.
Talks about it, it can be kind of confusing, and essentially the question is, if we know that the TEM electromagnetic wave travels, which is between the wires, travels down the wires at some velocity approaching the velocity of light.
Again, this calling it a wave, there's just no need to, it's one thing to be calling light a wave, but it gets even sillier when they start saying like a DC current or something is waving through a wire. It's just not necessary to think of it in terms of waves, because it's an actual substance. I mean, if you think of it as an actual substance, that you're pouring fluid into one pitcher, the pitcher overflows and it spills into another pitcher, and then it spills into another pitcher. You really don't think that as a wave of water or fluid.
Usually slightly less. And we know that electrons can only go a few centimeters per second, okay, within the wire. So how is it that the electron, since the electric field has to terminate on charge, okay, to be produced, how does the electric field, how does the charge in the wire keep up with the electric field?
Well, that's the part I don't understand. This thing about the charge has to terminate on, that's like, I don't understand that. What does that mean? That doesn't make any sense to me.
It's Gauss's law, because physics books say that charge creates electric field.
Yeah, but the electric field generally doesn't have to terminate on anything. If you have an electron sitting in the middle of space and nothing else around
well,
it,
you're just doing your typical scrambling up the discussion. That's the question, that's what it was.
So they just argue with each other, insult each other. Franklin and Harry don't like each other much. I don't like Harry. Harry's an obnoxious asshole.
As you asked where enough, I explained to you what it was, and then you launched into your confusing rhetoric.
No, what he's saying is why is this necessary to worry about this current thing when we know the voltage gets where it's supposed to go, so who cares?
No, I mean, that's electromagnetism.
I don't know, he's got a bunch of feedback, so this is sped up, but I don't know, now they got somebody else's mic is open, so the whole thing's turned to shit. As usual.
Harry, how does it not make sense?
Because they're only terminate to.
The electrons inside the wires.
So, yes, it is true that they talk of a drift velocity and electrons moving. I don't know, I'm not even sure which way they're supposed to be moving, like the wrong way. But clearly, it's just not a reality. The electrons that are moving just represent a voltage. They don't, I mean, an amount of energy. There's no need to have actual electrons move.
See, we're getting a pretty strong echo here. I'm hearing most muted except for Lou for speaking. And if so, then that may be just coming out of something going on with you, Harry. Whenever you talk, we're getting a strong echo. Maybe you need to speak a little bit closer to your mic.
Turn the speakers down.
Well, the echo seems to be gone, so I don't know what happened there.
It was probably my microphone. This is Bob Gray. Harry, I don't understand what the issue is with that description. Because if I put a length of wire, say a straight wire, between two very large capacitor plates, the capacitor plates generating an electric field, so that electric field is already set up. Now if I put a piece of wire...
There's no electric field, so the whole thing is kind of just a waste of time as a conversation. But whatever. There's no electric field created by electrons moving. Electrons are charged. They're magnetic monopoles. Obviously, if you move them, then you're moving magnetism.
Wire in there, all the electrons are going to move because...
Well, wait a minute. False assumption alert. The mainstream says that the charge creates the electric field.
The charge on the capacitor plates.
The charge has to flow in the capacitor from outside in order to create the electric field inside the capacitor.
All right. So, but this is a legitimate confusion in the way they describe things, because you're never quite sure. Is something that's charged actually collecting electrons, or is it collecting, okay, the polarization? That is, it's becoming, the atoms themselves are becoming more. Their face is more negative, more electron face, more. They're showing their electron face rather than their proton face. So it's back to this argument about if I move an electron closer to a proton, let's say the proton's this size. Depending on how close the electron is to you, it can wipe out the whole image of the proton. And if it's further away, then the electron's weak. And that's all that's really happening when you speak of charge. So they'll call that an electron moving to a place, when really all that happened was the atom expanded its electron.
Right. So I'm trying to understand, when I put this wire into that electric field, the electron...
A wire in the electric field, what are you talking about?
Well, you're talking about a waveguide and a pulse going through the waveguide?
No, it's a transmission wire.
I'm sorry, yeah, transmission wire. So I'm trying to understand, is he saying that the electrons don't keep up with the wave pulse?
Yes, well, again, this should say the word drift velocity. The drift velocity, as measured, seems incredibly slow compared to the speed of the actual movement of the pressure, the current. Anyway, so maybe we should jump ahead a little.
I don't know why you say that, because I totally base all of my answers on actual physical phenomena, such as...
You asked what the question is. Okay, the bottom line is that this was kind of ignored for a while, and then there were two answers given by two experts, and the experts that gave the two answers didn't really agree with each other. Okay, and then a few years later, recently, I think it was, I don't remember, in 2012 or 2012 or something, there was another paper that was written that sort of addressed this and sort of fudged the whole cat question and said, well, really it's kind of a meaningless question, and we can explain it with this Mexican way. Okay, and so in essence, basically, the problem, the issue of the question is, it's asking the textbook writers how they resolve this conceptual difficulty between what they teach, okay, in one aspect of electromagnetic theory and what they teach in another aspect of electromagnetic theory. Why can't they get together and agree when two sections of the book don't agree with each other? And that's kind of what it's about. And they essentially waffle on answering the question because they can't really answer it.
Okay, Harry, I'm going to have to ask you to not interrupt me, okay? I'm going to make a statement, and during the entire statement, I'm going to ask you not to interrupt. Okay?
Well, you asked me to explain it, and I did.
Yeah, so
you said that my explanation didn't make any sense to you because your opinion is superior, because you, as the moderator, have a superior opinion than anybody else.
And I'm just asking that I be allowed to relate my opinion without being interrupted.
Well, let's let other people ask questions instead of you giving your opinion.
Well, I haven't been able to give them a chance to give my opinion yet because you keep on interrupting.
Well, you don't know what you're talking about, Franklin. That's the problem.
Well, see, that's a violation of the science.
All right, well, we won't talk about this anymore.
That is a direct insult without any actual argument, without any actual scientific basis for that, right? You can't say...
Well, but you don't know what you're talking about, Franklin. You just make up stuff as you go along. So let people who do know what you're talking about ask questions.
Can I interject here?
Yes, please go ahead.
So, to use your suggestion, Franklin, of a pipe, let's fill it with air instead of water and make it miles long. And if I understand what the cat question is, the analogy would be to put a pump on one end of this several mile long pipe that's filled with air to pump more air in. And as you start to pump air into one end, the pressure increases. The pressure would be the field that's being generated, okay? Because those are being compressed at the end and they're starting to move down the pipe. But the ones at the other end, miles away, haven't felt that movement yet.
Yeah, there's no field being created. So again, just keep talking about these moving charges, creating a field. The moving charge is essentially just, again, a metaphor for the pressure moving. And that's all that happens. There isn't any extra thing happening. It's a charge. Electrons are charged. And if you change their location, okay, in proximity to a proton, you'll change their effect. They're effectively changing what their charge is. They could have a charge of 1, but if the charge of 1 is really close to you, it matters more than if it's very far away from you. And, you know, they're just... conventional physics doesn't get that, and they don't get that either, so... But it's hilarious. The hairy guy is so rude. He's just so obnoxious.
Although the pressure increases the same as it does at the other end. I think that's an analogy. Tell me if I'm wrong, Harry, of what is being described with the transmission line.
Well, I think it's a good analogy.
Not really. You have to understand basically that the model that you just described is the model that's used to describe what happens in an electric circuit. Okay, so you put a battery, okay, and you apply that battery to a wire, and the wire is connected to some kind of a load.
Yeah, that's the same as transmission wire, so I don't know how he's going to undo that simple argument.
Like a lamp bulb or something. And the textbooks say that the battery sets up an electric field inside the wire, which is like your pipe, and that causes the electrons, urges the electric field that's set up inside the wire or inside the pipe, affects the electrons and urges them to move from the minus to the plus, if you're talking about the electric current.
Yeah, but that's what I'm saying. That's a convention. It doesn't really happen. All they're saying is that there's a certain amount of pressure that ends up moving from one end of the wire to the other end of the wire.
Current, or what's the physical electric current as opposed to the conventional electric current. Do you understand what I just said?
I'm not sure I understand between physical electric current and the other.
Well, conventionally, when you do an analysis of an electric circuit, you assume charge flows from the plus to the minus.
Okay.
Right. Electrons move from the minus to the plus.
Well, regardless, in this pipe, I'm assuming the air molecules as representing the electrons.
So again, he just said how the convention is to have charge going the wrong way. And so just saying, the point is you just have to ignore their conventions. Because they're for mathematical purposes only. Again, it's the whole Maxwellian problem of splitting electric and magnetic fields into two different kinds of things when it's all one phenomenon. And that's why they cut the speed of light in half and have mu 0 and epsilon 0, you know, being the constituents of the speed of light. It's superfluous.
In the wire. But,
yeah,
but the pressure that supposedly zips down the line at the speed, or down the pipe at the speed of light, is the field that we're seeing with the cat question.
Yeah, that's the speed of sound. I mean, if you put a speaker at the end of your tube and you turned it on, that sound would travel at the speed of sound. Very fast.
Correct.
Well, depending on what the tube was made out of. So again, you make it out of steel, it's going to go a lot faster than the speed of sound. It'd be the speed of sound in steel.
Now, if you were to just keep on pumping air through one side, as opposed to a pulse that a speaker could put on. So I think this analogy is very good because it exactly shows why is it that the migration rate of the actual electrons is much slower compared to the wave that can go through. So in your tube of air, when you do the initial pulse, like we had a little explosion, at one end of that pulse would travel at the speed of sound to the other end. And the actual air molecules themselves wouldn't actually move. They just go like that. Boop. This is what they did. They go boom.
They actually do move. So I don't even know if that's quite true, to tell you the truth. I think you can move pressure faster than the speed of sound. Sound is a specific kind of moving. And so I'm not sure he's right on that one.
The pulse would go through, and the actual molecule does not move. But if you were to have a fan or something, then you would actually see the slow migration of the air molecules.
I mean, we know that water is completely uncompressible, but we know sound can travel through it. Sound's pretty slow, but if I make a pressure on one side of water, it goes through the water, I think, faster than that. So it's uncompressible.
From one end of the pipe to the other. Those are two different operating regimes, and I think Cat is confusing both of those. But if
Excuse me, why do you think you made an assertion? You based your assertion on a model that's not correct. You're just using
no,
an
the thing is that Cat's model
I'm saying that your analogy demonstrates that Cat is confused. How does that work?
Because Cat doesn't understand that the wave, which is like sound wave, travels very much quicker than the net migration of the electrons. He's complaining, like if it's truly the problem that he can't explain why is it the electrons don't catch up with the wave, then that is fully explained by the same analogous situation of the sound of tube filled with air or water or whatnot.
The tube filled with air is a wrong analogy.
No, that's a total.
Yeah, no, it doesn't make any sense. You can't have a drift velocity and claim that there is electrons just drifting at a much slower speed than the actual voltage is moving. So what sense does that make? And the actual current is arriving. So it really does not make any sense to worry about this notion of a drift velocity, because it has nothing to do with either the current or the voltage. So Franklin's wrong here.
Totally right analogy. I mean, if you accept that as a physical model of reality for what's going on in the electron and the wire, and that's what mainstream explains it as. I mean, mainstream explains.
So you're saying basically I refute Cat based on an incorrect model of what I claim is happening. So my incorrect model can be used to refute a question.
Physical model.
Well, it's an incorrect physical model. I told you that at the very beginning.
What's wrong with it? It's an absolutely correct physical phenomenon. That actually
electricity is an air in a tube, Franklin.
Yes, electricity is exactly like an air in a tube. If you're looking for an explanation,
basically what we've established is that people have wrong concepts, different concepts of electricity, some of which work, some of which don't work. And your analogy of the air in a tube doesn't really make any sense as far as the facts of electricity are concerned. But that's what you want to think about it and how you want to think about it. I can't convince you that you're wrong.
Because it explains what's happening. It eliminates this whole cat question.
It doesn't explain drift velocity. Okay, so with sound, you don't have anything called the drift velocity. You're not going to detect some kind of, but the actual atoms are drifting at a certain velocity. No one's going to talk about a drift velocity. So again, they're just missing the term drift velocity in this conversation. If they would just say drift velocity, then they could get what they're talking about.
And how was the energy carried in that analogy? But did the electrons exert some kind of a pressure at the end of the wire?
Well, the analogy there is that they have some.
No, we're not talking about analogy. We're talking about how the thing actually happens physically. We don't want to talk about
analogy. Yes, but the moving electrons do have an impact upon the matter that is absorbing the energy. Like would that be a light bulb or a fan?
Right, well, explain me this. Okay, the electrons are going down the wire, coming out of the battery, and they go into one side of the light bulb, and they come out of the other side of the light bulb on the other wire. But the current that goes in is the same as the current that comes out. So how did any power get transferred to the light bulb to light the light bulb if the electrons going in, the current going in is the same?
So again, this is the whole problem of thinking in terms of electrons actually moving when, again, they're just going pressurized, unpressurized, pressurized, unpressurized. That's the only thing that changes. There's higher pressure at one end that just keeps coming, high pressure, and it keeps getting exchanged with every atom that's at lower pressure. So as long as there's lower pressure, as long as there's something that absorbs pressure, so as long as the atom next to it isn't the same pressure. So if the atom next to this one is the same pressure as this one goes big and this one's already big, well, this is not going anywhere. There has to be a place for it to go. It has to go from high pressure to low pressure. And it's really that simple.
When is the current coming out? How did that happen?
Any electrical engineer would tell you that while the current coming in and the current going out is the same, you would notice that the voltage on one end compared to the voltage on the other side is in fact very different. That the voltage on the exit.
So what? How does that explain how the power got conveyed to?
The voltage always ends up being zero in the end, though. So that is, you always get rid of the pressure. It always goes to the ground, which is the neutral pressure, this pressure, and there's pressure below it, and there's pressure above it. So you can be this size, or you can be this size, or you could be this size. But the ground is going to always suck anything bigger than it. It will allow a pathway. So you're always going to end up at zero when you're done.
To the light bulb.
Well, that's exactly the same way we generate power in hydroelectric dams, which is that we have water, which is a very high point, which is at higher potential. It goes through, releases that potential as it spins the generator.
How does that do that in the light bulb, Frank?
And then the water is in at a lower level.
How did it do that in the light bulb? The electrons came in, they don't have any voltage, they're just particles in a wire, and they're just going along in a flow, and they go through the light bulb, and they come out at the other end, they're going at the same speed. So how did they do that?
Lower pressure. That's the key there.
Electrons don't have pressure.
Yes, electrons have pressure. It's called voltage.
No, they don't.
Yes.
So again, it's saying electrons don't have pressure, which doesn't make any sense because of course they hate each other, and that's a pressure. So you can't push an electron into another electron. So to say they don't have pressure would be kind of silly. Obviously, the atoms have pressure. That's why you need a conductor to move electricity, is because it's the atoms that are forcing the electrons to be in proximity to each other and therefore exchange their pressure.
Yes, they do. That's what voltage is. It's electron pressure.
Okay. So when the water goes over the dam, doesn't it have less energy at the bottom than it did at the top?
Yes, and that's why.
Well, how did the electrons lose energy going through the light bulb?
Well, the way I believe it happened, and this is a matter.
Wait a minute. You believe?
Yes, well, you're asking for an explanation because currently, you ask mainstream, they would basically have no idea.
How did the electrons coming out are going at the same velocity as the electrons going in? How did energy get conveyed to the bulb?
Like I said, it's a difference in voltage. The difference in voltage is quite critical. Now that voltage got removed because basically when the electron moved through the tungsten filament.
Well, this is really easy. He's asking you to explain the hydroelectric example, and it's the momentum is obviously being exchanged. So the thing that's moving is hitting something not moving, and it's causing it to move. It's sharing its movement. By sharing its movement, it makes the other thing move, and that's all. So it's the same principle. It's a non-moving thing and a moving thing. A pressurized atom, an unpressurized atom. Same difference. One's got more stuff, movement, pressure. It's being pushed. It's moving towards you at a certain speed, and the speed would be the voltage.
Right, it has very high resistance. What resistance means is that it's the affinity for an electron to the atoms. So basically, they're sticky. That when the electron comes by the atom,
up stuff, Franklin.
Yes,
I know electrons whatever. What you're talking about.
What's wrong with making up stuff? This is how hypotheses are done, right?
Well, I'm asking you the question, and you're just making up an answer.
Yeah, well, he did say that's what everybody's trying to do. They're trying to make up the right answer. So he's giving you what his answer is. And it's just like Harry saying, no, you're not allowed to have an opinion.
Yes, and that's how science is done.
You don't have an answer, okay? Admit it.
That is an answer. Anyone can make up an answer, right? I could say that what happens is that little ghosts are sitting there and they spin around, and that's what's happening in the light bulb. I could say that, but that doesn't seem very plausible now, does it? I'm just saying that.
All I know is that if I understand it, tell me if I'm wrong, but if I have a water wheel and water is coming in, it turns the water wheel, it seems to me that the energy of the water that flows out of the system of the water wheel that goes down the stream has to be less than the water that came in and hit the water wheel and caused it to turn, because some of the energy has to go to the water wheel, right?
That's
so
correct.
that tells me that the energy or the velocity of the water that goes in has to be more than, less than what comes out. But in the case of electricity, the electrons are going in at the same velocity that they're coming out. So how did they lose any energy?
They're not moving. So that's the whole point. By the time they get to the end, there's no voltage. There's no pressure. All the pressure's been used up. So that's where Franklin and I just say, no, yes, you're quite correct. All the voltage has been used. That's why it goes down to zero at the other end.
Well, I mean, I think that what you just pointed out there, that with the water wheel, I mean, obviously, the flow of water coming into the water wheel and the flow of water coming out of the water wheel is absolutely the same, right? It's totally the same.
The amount of water, so he's saying the flow, and he's messing up the velocity argument, the energy. Obviously, the water is leaving a lot slower than it would have left if you didn't take all the energy out of it.
It is. We know that for a physical fact.
How do you know that?
Because if it wasn't, it would well up like a dam.
That's right. It would well up like a dam. I mean,
so you're telling me that the light bulb's going to get full of charge?
Yeah, it would if if there was any difference in the flow of electrons from one end to the other.
They're the same.
Yes, and it has to be the same. It must be the same.
So there couldn't be any energy. There couldn't be inner energy going into the light bulb if the velocity of the electrons going in is the same as the velocity coming out. So it's the same. Going in is coming out. So there's nothing happening there in that light bulb.
No, again, it's, he's just not getting the difference between the velocity of a pressure, the intensity of a pressure, and how fast that pressure can possibly move through a medium. So it's like sound. You can have a very high frequency sound, or you can have a very low frequency sound. They're both going to move the same speed. So he's just not getting it.
Well, you could say the same thing about the water wheel, because the volume of the water coming into the water wheel is exactly the same as the volume.
Well, I don't really like this analogy.
And therefore, you would say that the water wheel can't extract any energy either.
Well, if the velocity going in is the same as the velocity going out, it would seem to me there's no energy going into the water wheel.
But we know there is energy going to the water wheel, so there must be something.
So Franklin should just point out here that, no, the velocity is changed. All the velocity going down, none of that velocity was realized. None of the acceleration was added and created velocity. And the water leaving the water wheel is going much slower than it would be going if you just allowed the water to pour down a slope. So he's screwing up his own metaphor, which they often do. Alright, let's jump ahead a little.
Telling me electricity is water in a pipe, like water in a pipe, now we're talking about waves. Why are we doing that?
Because water in a pipe also carries waves. And you can see that if you had a pipe and it was closed on one end, and you put like an explosive
So
trap
waves are, what's the electricity? The waves or the water? Tell me.
It's a wave has to have a medium. Those mediums would be either the air particles or the electrons.
Right, so he says waves have to have a medium. So again, why are you calling the medium is atoms for electricity? And we know the atoms aren't moving. You know, they're not going anywhere. They're the medium. So why don't we just acknowledge that all that's changing is something, a character of the atom, whether it has electron pressure, that is photons, extra photons between the electrons. But see, they don't even understand what a photon is. They don't understand that photons are essentially the force that's inside the wire. It's photons. That's why it almost moves the speed of light. It's because it merely has to push the electron a little tiny bit. That slows it down, but most of the movement is at the speed of light, because most of the movement is happening ping pong balls between ping pong paddles. So more pressure over here means this paddle tilts. That means there's more pressure here. That's all that's happening. I shouldn't say tilt, because that just indicates, well, you have to tilt back. Because technically what you have to do is get big, and you get smaller, and then you get bigger, and so it's the same idea as tilting. You do have to tilt back, but because the pressure is constant, you never really have to.
So if you have a closed tube and you put a sound input wave in one end, it will travel to the other end. And it doesn't involve the net migration of the air or the electron molecules. That's how that happens. So that's how I explain that.
Where it's appropriate, we should be using the word propagate instead of flow, where it's appropriate.
Yeah, I think that's correct, because when you have wave propagation, that doesn't imply that there's a net migration of your medium from one end to the other.
Good, yay, you got that part.
When it comes to electrons, it can actually migrate from one end to the other. But in order to...
yeah, but that's what they've never really proven, that that's what happens. So I guess that's an argument that's left open, because you'd sort of argue that if the electrons actually did move somewhere, then they'd be doing like what electron guns do. And we know that basically melts a surface, and that's where you're getting the electrons from. You're taking them off the surface, and the surface degrades. The anode and cathode char, they burn. They're used up. So when you actually do produce electrons, you do have to burn an atom to get electrons. So you could argue that the whole perception of this idea of electrons building up on a surface might be wrong, and all that's really building up is the pressure between the electrons. You're just making the atoms fat. Okay, you're just making them fat or thin. Fat or very thin. Very thin, very fat. That's positive voltage, negative voltage.
Get a reaction from A to B does not actually require that actual motion. All you need is the propagation of a pressure wave across that medium to see those other effects. So once again, you're operating in two different regimes, and you have to be able to understand that those two things are completely different. And so you can't...
Yeah, I know, but you're saying the two things are happening, and the two things aren't necessarily happening. Electrons aren't really moving through the wire. The pressure is just moving through the wire.
I think they're completely different and not the same thing. That's where the problem arises. As long as
different
hold on. What you're saying is, I can explain this way when I'm posed with this difficulty. And when I have another difficulty, I'll explain it in a completely different way. No, that's not really how you do it. You have to have one correct explanation for both cases, and you're done.
Because in both cases, there is a particulate medium constrained by...
All right, so let's try this one more way. So let's say that you do have a supply of electrons trying to get in. Okay, they're under pressure, and they're pushing against electrons that aren't under pressure. So you could imagine that they can just exchange in an atom. One electron pushes into the other electron in an atom and just replaces it. So it takes this spot and it pushes this one in here. And now this one doesn't have any home. And it pushes against the next atom and takes its spot and then moves along. So you could move actual electrons through the process. But how integral is that to the actual movement of the pressure through the wire? So that's where it gets, I guess, kind of complicated. So I would argue that you don't need an electron to move pressure. But you could move electrons.
Another biophysical barrier.
Okay, so radio waves don't have a particulate medium. They go off into space where there's no wires, there's nothing connecting them. So
Yeah.
Right, they're just photons, so that's the simple explanation, right? We can move lots of energy without any conductor by just using the photons themselves. And if you're moving them through a conductor, then they need to jump between electrons to move, because there's a bunch of atoms, you know, and the stuff can't just fly through, so it has to, the photons keep hitting the electrons. So in a sense, yeah, and it's the geometry of those atoms that keeps the energy in the conductor. So if you use something, you could use a conductor that can't take it and it'll melt. You could use a conductor that, so there's lots of ways you can, you know, destroy the integrity of the conductor because the energy is too much for what the conductor can stand in terms of the amount of movement of electrons.
Evidence that radio waves, in fact, must be a particulate medium.
radio waves are a particulate medium?
Well, radio waves indicate that there must be a particulate medium of some sort in order.
So you're saying that because radio waves exist, therefore...
So, I mean, Franklin's, this argument that somehow you can't imagine anything moving in the universe without a medium to move through, again, it's just, why? So, I don't, you know, Franklin keeps saying that, and there's absolutely no reason for me to say, why do I need dominoes? So there's a trail of dominoes that goes from here to here to move something, this, you know, movement. Well, why can't I just throw a domino to the other side? I mean, he's saying somehow that can't happen. Dominoes can't fly there. Why not? Dominoes can move this far, all right, between the dominoes, right? The dominoes have to somehow move into each other. Well, if they have to do that, why don't I just make the movement this long instead?
For your theory, in order to be correct, must make the assumption that there's a medium for radio waves.
Absolutely. That's a logical A to B reason.
So there's no experiment has ever shown this medium exists.
Well, because we don't know what it is, and it's kind of hard to find something that you don't know what it is, right?
Well, you know where it's supposed to be, and you still can't find it. You know what it's supposed to be, the implications of its existence are. So you just know that every medium, we can certainly detect water, right? You can stick your hand in and go slosh back and forth. Say, yeah, I can see the medium. Most mediums are pretty detectable. So why is your medium not detectable? Most mediums, by the very nature of the idea that they're creating tension, create drag or create some other symptom that you should be able to detect.
First of all, we'll have to know what it is, then you can go out and find it.
And not reasoning, frankly.
No, that's perfectly logical reasoning. In order to find something, you must know what it is.
They've been looking for it for years and years.
Again, I mean, it's silly. To order to find it, you must know what it is. No, you already do know what it is. You just called it a medium. Mediums have properties. You can find those properties. We know that the implication of something under tension is that it's going to create drag.
And years and never found it.
That's because they are likely looking in the wrong place. I mean, most people who have ether theories, their theory just grounds out as a postulate, saying that there's, the mysterious, ether things, right? And they can't be found, and that sort of thing.
So it must be there in order for you to...
I can almost predict what you're going to say, though. But go ahead, Michael.
Well, in the Michelson-Morley experiment, they supposedly disproved an ether medium by using concepts like ether wind and rotation of Earth, and is it a stationary ether or a dragged ether? But this is in my ether model, which is not...
Oh, I'm not even going to do this. Yeah, this guy is a real loop-de-doo. My ether model, he's just way out there. Crazy.
Atomic distances, or distances we're familiar with in everyday life, because it's a very tenuous substance. But I would say that we know certain properties of it. We know electric and magnetic properties. We can also reduce a conductivity of the ether, a non zero.
So a conductivity of ether, it just doesn't make any sense. But okay, whatever. I just don't understand why people are so glued to this ether crap. What do you need it for? I mean, you're just saying that, okay, a rock can't fly unless there's ether. At least there's a medium. So I give the rock velocity, I push all of its atoms, all of its little bits are moving, and somehow you're arguing that somehow the bits need some sort of ether to move through. That they can't seem to just move because I gave them velocity. Yeah, they can.
Conductivity. It's very, very small. It's non-zero. So you can get a breakdown. If you have a high enough potential between plates, you will get an eventual breakdown. If there were no conductivity, of course, you wouldn't get a breakdown. You'd need an infinite potential before that happened. So you can find that this conductivity does actually reduce the momentum or reduce the energy through dissipation in the ether. And I would claim that's basically responsible for what...
Well, that's just nonsense, right? Because you don't get any breakdown in outer space. I mean, the breakdown voltage in outer space is like 10 trillion volts or something.
We frequently attribute to the redshift, Hubble redshift.
Well, that's an interesting bit of that I hadn't heard of. But I can believe that. So you're saying that if there were no ether, then, you know, assuming we are able to produce a perfect vacuum, then no amount of voltage should be able to cause a spark to jump between those two plates. But you're saying that since we do observe that there is this conductivity, that there must be something that it can actually bridge the gap. So that would, you know, in contrast to Harry saying that there is no experimental evidence, well, that would be an experimental evidence saying that there is something that has measurable properties that allow physical properties like a spark jump to jump across perfect vacuum to happen, right? So I think that's very interesting.
Okay. So what is this ether then? What is it?
Well, you asked me, it's a positron electron C. I've been saying that forever. So.
Yeah, it was just absolutely nonsense. A positron, silly crap. Anyway, so I don't know what they just asserted there, that they have, they're making sparks in outer space. I don't think so.
I think to conceptualize the ether, you have to realize that there is an etheroidal transitional process going on in which quantum units, quantum water units are formed, and that you're talking about also an elemental ether, which is vastly more rarefied, and where actually I believe all these energy things start because it's
more rarefied
perfectly
ether.
Linear.
Pure ether versus dirty ether.
Identical element.
Oh, it's just nuts.
That if you reacted a positron electron, it would go back into the sea, and you wouldn't be able to see it. And that's, of course, exactly what we see.
Okay, so assuming that it's a positron electron C.
A positron electron C doesn't make any sense because it all stick to each other, right? Fine. So what sense does that make? how could it? The positrons and the electrons would somehow have to keep converting into each other or something. I don't know. How the hell could that possibly work?
How does this positron electron C? How does that cause electricity to do what it does?
Well, electricity is a flow of electrons through a wire.
Wait a minute, now you contradicted yourself. You said, well, it has to be something to do with the ether, and now you're talking about electrons flowing through a wire.
Because the ether is the medium on which everything sits. Electricity is the specific phenomenon of electrons flowing through a lattice, an atomic lattice.
Franklin?
You say that electricity is...
So how do photons travel through positrons and electrons?
Ether. No, electricity is not ether. The ether is, say, the positive electron C, which surrounds everything. Electricity is...
So I put a photon into your positron electron C. I put a photon in, and somehow a photon comes out the other end. How exactly does that happen? Never mind.
Specific physical phenomenon where electrons migrate from one end of an atomic lattice to another. Right? So you have a comment.
Yeah, I actually have a few comments. One, there are plenty of theories that suggest there is an ether of different types. The one you mentioned, quantum foam. There's also quantum loops. There's also quantum strings.
Oh, shut up.
Such as quantum foam, quantum electrodynamics.
Jesus. Quantum
rather than electrons flowing within the metal of the conductor itself. This is sort of the cat idea again.
Yes, and again, when you talk about the flow of liquid in a pipe, it has to expand when it goes from a higher pressure to a lower pressure.
Yeah, water doesn't expand, so that doesn't work either.
Well, it could be a combination of both.
I also object to this notion that we have to assume that ether is made out of known particle. I think that we should accept the possibility that there could be a different kind of particle that we haven't detected, because it's too small.
and possibly can't ever protect the actual particle directly.
I absolutely agree with that. But that make it kind of hard to find, right?
But we can still tell that there is one from the indirect evidence. The problem is that when the Microsoft came up empty, they jumped to the conclusion that.
Again, it really doesn't matter how small you make it because the drag would still have to exist if it has tension. So again, we know geometrically you can't make your ether out of something because then you lose straight lines. You end up with diagonals. There's no geometry for an ether of particles.
There was no velocity.
Yes, that was quite a jump, and not just the
velocity, but their instruments were too insensitive to detect.
Agreed. I believe we can easily infer it based on the topology, the shape of it.
It's like on a checkerboard. You only have certain moves, right? I mean, you got a 45-degree angle, you got this way, you got a 45-degree angle, you got this way. That's all you got. You run out of choices of direction when you create a ether out of something.
But now my argument would be is that if we sit there and we accept the existence of ethers we can't detect, then we are potentially just going down a blind alley, and we're wasting perhaps wasting once again a lot of time and effort going down a blind alley.
What about all the crazy particles that modern physics finds?
And we found them, so we know that that's not a blind alley.
The ones haven't been directly detected. They're only
Well, those things don't exist. Quarks don't exist, I don't think. A lot of those things we haven't actually existed don't actually exist. They're virtual.
They're not. They haven't been directly.
No, they're not virtual. They literally don't exist.
They're mathematical constructs.
Okay, I'll give you that. I think that they may be mathematical constructs.
But whatever about that, I mean, it's a question of one's interpretation. For example, I would say that the ether has been detected because I would interpret experiments such as the Sagnac experiment and the Michelson-Gale experiments as being a detection of the ether. And one can explain them in terms of that. But others who don't accept that would say, no, it's a detection of, I don't know, non-inertial movement or something like that.
That's why you need to have a Michelson-Gale experiment.
Yeah, well, again, this whole reliance on experiments that are technically, you haven't even explained how interferometers even work, you know, and then you're saying, I want the results of what it's proving, when you don't even know how it works. And, I mean, as I've pointed out before, you have to understand that atoms somehow produce photons, and atoms somehow catch photons. And the process of producing and catching is another thing you have no clue about. So how can you talk about the timing of throwing and catching when you don't know how they do that? Just as it would take, like I said, I've made this train analogy before, but if a train is traveling, you know, 40 miles an hour, and I want to throw something off of it and have somebody catch it going 40 miles an hour, I have to throw it 80 miles an hour. Because I have to overcome the movement. I am running away from the guy at 40 miles an hour. I have to throw 40 miles an hour just to get to zero, and I have to throw the extra 40 miles an hour for him to catch it at 40 miles an hour. And none of that is in the calculations of what happens in the spinning interferometers.
That shows that.
And one has that, as we discussed before, you know, the Brillouin whole business, which, as you said somewhere in the chat here, all these things are being misinterpreted as magnetic effects. They're being interpreted anyway as noise, and if you look at them in more detail, you find they are showing up this relative motion of the spin of the Earth's surface, and the more static ether.
I mean, I think you make a good point there, Ian, that if Michelson morally defeated the ether by showing that they didn't see a flow, then you're right that the Sagnac experiment does show that there is a flow. So that basically negates Michelson-Morley's result. You can't find no results with those experiments. And I
think it was explained at the time as a successful detection of the ether. That was actually the description of the experiment.
Yes.
What is ether? I mean, now, essentially what you're saying, the ether is detected, but what is it? What is it that they detected?
Well, like you say, Harry, when we talk about ether, we're talking about some substance, physical substance.
What do you mean by substance?
Like, me, I'm made out of substance. I'm made out of electrons, positrons, and neutrons.
Yeah, but you read what he says in his emails, he defines substance as something that's not material. So, I don't really know. First thing you have to tell me is, what is this ether? Is it material or not material?
It might.
Well, it doesn't matter if they detect it, that's fine, but the Sagnac experiment is just another spinning interferometer. It didn't detect anything. Pile of crap.
That provides opportunity to create non-cooperation. So you get this out of balance going to be out of balance. There's going to be a counterbalance that's displaced, physically displaced from, so you got a balance, an out of balance and a counterbalance, and those are what orbit and become electrons.
Like that's an explanation. I mean, amazing. I mean, the stuff people say, there's a counterbalance and an outer balance, and then there's a swirl in the toroid, and the swirl in the toroid makes an electron. Yeah. Oh yeah, I visualize that. Oh yeah, sure, I get it. No, I don't get it. All these complex forces creating very simple things. It's like they have this huge, giant schematic for this complex little photon engine. It can't possibly be a rock that just moves the speed of light forever.
Is responsible for the charge of the electron, so
yes, it is.
Circular reason.
That's the beauty of that theory.
If you've been told this for years, Franklin, that your theory is circular reason.
No, that's not circular. That's the beauty of the theory.
You say that the field of the electrons and the positrons exist independently of the electron and positrons, and then you say that they're the ether that allows the fields to exist. I mean, this makes no sense.
No, actually, that's
okay, well, let's go back to what Alistair was saying.
This is how we explain many phenomena with just one underlying phenomenon. Now, I don't know why you have difficulty understanding this, but it's as simple as when the positron and electron come together, they neutralize that wave that's coming out of them. That's why they're attracted.
Well, you don't have any medium for the wave that's causing the electrons and positrons to bind together. You have to have a medium for that, so you have to have an ether to explain the ether.
No, what happens is that if you think
I'm sorry, let's just let Alistair talk.
That if the positrons and the electrons are like these pulsing things, right? Now you have one individual electron that will send out waves, right? Because it's pushing the things.
There's no medium for the waves.
Yes, exactly. It doesn't make any sense. So now he's saying electrons sending out waves. Well, waves in what? I thought they were the ether. That is a second ether.
But the thing is, between a positron and electron, there is no medium. But when they're like this, they don't occupy varying amounts of space. As soon as one gets bigger, the other gets smaller. So therefore, this particular object does not generate waves. And the only reason why it sticks together is just a matter of geometry, and that it's the lowest energy state for it to have. Because as soon as it gets together with something which is also pulsing the same way, it's going to push it apart. Therefore, that's not the stable arrangement. But if you just have two that are just going like this, that's perfectly stable. That forms essentially a different object which isn't pulsing, and that's all you need for immediate image.
Right, but if they're oppositely charged, it's not going to work. So I don't see the point in that. You might as well just make them all positrons or make them all electrons. But still doesn't make any sense.
It's a neutral medium. So that if I have these guys out here that are going like this, but I have one guy out here that's just doing this, it's going to, that these guys, which are the joint particle, they will act as the medium.
The medium's got to be something smaller than photons. So again, this whole idea of making a medium out of something as big as electrons is just retarded, frankly. That's like the checkerboard problem, in an obvious way. The bigger, if the medium is as big as electrons, then the photons won't have very many choices in terms of what direction they can move in, and so you'll lose like all the freedom that photons have to go in almost any direction.
Yeah, to transmit the pulse from the one stationary electron, right? So, like I said, this is beauty in that I can explain the transmission without there being any other ether. I mean, I do have to explain that these particles, which are in opposite phases, that when they're actually together, there is actually no medium between them, and that the only reason why they're staying together is because if they weren't in opposite phases, in the same phases, they would push each other apart. So therefore, even with them, so if you were to look at the force between the positron, joint positron, electron, we'd find there is no force. And this is the same thing that we see inside of a proton, that, they say there's...
Well, except there is a force when you put force into one of the electrons or the positron. So something has to disturb the balance, and I don't know how it can possibly disturb the balance in any kind of positive way. But whatever. Too convoluted.
There's three things in the proton, but strangely enough, they find out that those three things aren't bound together by anything. They seem to be like a loose bag. There are no forces between them. And that would be consistent with the idea that once you get a positron and electron actually together, that there is actually no actual force between them, because there's nothing between them to mediate any kind of force. And at that point, it just becomes geometry as to why they stick together. Because as soon as they get far enough apart, and if there allows medium between them, then the actual attraction will happen. And this also solves the problem of, but it would be theoretically infinite attraction between a positron and electron if you were allowed, if their attraction worked at all scales. And this would definitely limit the attraction force would fall.
But then you're ignoring what exactly is attraction and repulsion made out of. So again, it just kind of is ignoring the fact that you have to have a medium for attraction and repulsion. You have to have some mechanism. You can't just say they're attractive or they're repulsive. What's making them repulsive or attractive? And no explanation of that.
To zero as it drops below the frequency, the resonant frequency of the positron electron. So I'm trying to show that that's beauty. That's not circular. That's beauty. That we can explain that the medium itself is made out of and can transmit the individual pulses from the non-joined particle, like a separate electron. Only a separate electron can emit this field around the electron. It also solves
again this field of what? Eesh.
Where does the electron get the energy created field? Which is that
particle or the field?
Pardon?
What's worse, the particle or the field?
What is what?
Well, based on your theory, basically, it's a chicken and egg theory. Basically,
no, it's not.
In order to explain something, you have to have this particle, that creates the field. But then you're starting saying that the field creates the particle. It just
no, I'm not saying that. All that. What you need is actually physically a particle which takes up more space and it takes up less space. Truly, that's physically the only thing that is required.
So you need space.
It has to get bigger. It has to get smaller. That's it.
In my case,
that in Newtonian physics, and only Newtonian physics, you can get the creation of a neutral particle, which needs.
So again, that would make no sense if the whole thing is in tension, right? Because then every particle that went like this would be vibrating in every single direction. That didn't make any sense, right?
Either expands or contracts, so it doesn't have, not surrounded by the field generally. But it still allows separate particles to generate fields which do create attractive forces. So that's, eventually your theory, in order to be valid, has to basically boil down to just Newtonian mechanics. At no point can you invoke anything other than objects colliding into each other.
Like charges?
Yes, so charges can.
Yes, items colliding into each other, right. So why don't you just make the forces that seem to be doing all the colliding and forcing things to move, why don't you just make them the moving thing and have all the other stuff stay doing nothing until a force hits it, till it gets hit by something. So again, he's just... why not go with the obvious, that there's stuff moving the speed of light that cannot be created or destroyed. That means you can only absorb it, you can collect it, a little bit of it can hit me, I'll keep it, keep its momentum for a while, and then I'll move, and then I can release its momentum and stop moving. Simple enough.
Can be explained in purely Newtonian terms. Of course, you would have to accept my main postulate, which is that an electron is this kind of pulsing particle.
In the case of my universal building block, the shape of...
Pulsing from what? What is the cause of the pulse? And how does the pulse move in straight lines?
It has ridges, which get bigger and smaller as they go around the particle. So when the particle spins, they are half expanding and half contracting at the same time, just based on its physical shape, with no charges, no forces.
Yes, but how does that help generate the primary observation, which is the attraction of a positron and an electron versus the repelling of an electron to an electron? That's the basic thing you have to explain.
Because the field is full of rotating particles, which are half getting bigger and half getting smaller all the time. So every point can be considered to be expanding and contracting simultaneously based on the shape.
Simultaneously, so yeah, you're already done. It's bigger and smaller at the same time. No, it isn't.
To serve as the medium for the wave that's coming off the independently unbound electron. So there's no contradiction in that. None of that involves using the concept of, say, charge or anything other than it just relies on medium.
Well, what differentiates an electron from a positron if not charge?
Well, what differentiates them is phase. Because otherwise, an electron and a positron would physically be exactly the same thing, and they are. They have exactly the same mass, same magnetic characteristics, everything's the same. So how can you get two...
Yeah, nothing's the same in the sense that the electrons are easy to detect and the positrons are not easy to detect. Can't do anything with them. Can't they're always, if they exist in some circumstance, they exist as a theoretical existence, not an actual one. Go ahead and show me the positron gun. You should, theoretically, if it's exactly the opposite of an electron, you should be able to make an opposite CRT. Just reverse it. reverse the voltage, and you should just be able to shoot a bunch of positrons at the screen.
Things which look exactly the same be different.
What's a magnetic characteristic?
Then it can be deflected in a magnetic field. It's just it goes in the opposite direction.
What's a magnetic field?
Well, the magnetic field, as I've explained, is a polarization of the dipoles. Wait, if you can get all the dipoles that point in one direction, but normally in non-magnetic space with no magnetic field, they are range.
Right, but what is the force made out of? What's the actual stuff? The creating the force.
But in a magnetic field, I believe it's like wind blowing through a set of flags. It causes all the flags to point in one direction, right? And then when you try and send an object through those flags, it gets preferentially deflected. So that is a magnetic field. That's why I feel that your ether has to be able to support this concept.
Right, so there's flags on the positrons.
Concept of vector, which is a direction.
When you talk about electron-positron pairs, do they fill up existence totally?
Yes, they fill up existence totally.
Okay, so it's electron-positron, electron-positron, electron-positron in a long line?
It's more like a gas, but a very compact gas, I would say.
Well, it can't be very compact, but in a sense it has to get more compact when there's matter. So obviously we know there's density issues, so if the same ether is making all of us, we know that obviously some things are thicker ether than other things. So that doesn't work either.
So then, what's the next one above it look like?
Next one above what?
Well, you've got an electron-positron pair.
Yes.
What's right above it?
What do you mean above it? I don't know.
How's the atom work inside of the ether? Is the atom made of ether, or is the atom a displacement of ether?
This is three-dimensional.
Yes.
Okay, so an electron-positron, what's around it?
More positrons and electrons. It's a C.
In what configuration?
It's got a couple H2O. It's a C just like water. What's above
right.
it? More water.
When on the water, you can see a configuration.
That's right. You can see a configuration, and the dipoles even also have a configuration.
If you have a bunch of balls on a billiard table, let's say you fill the billiard table up with balls, and then you put more balls on top, and then more balls on top, and then more balls on top. So now you've got a square brick, the size of a pool table, filled with billiard balls.
Yes, and
then there's going to be a configuration. They could either be square, sitting right on top of one another, or they can be hexagonal. Maybe there are other options, but those are the two that are the most commonly known. So
well, if you take a barrel and fill it with ping pong balls, they will naturally take kind of a form. But I feel that the ether C is more liquid than that. So
okay,
but I don't think that's a particular important detail.
At its basic, is it hexagonal or is it square?
Probably, if it's closed packed, it's hexagonal.
Then that's where I run into the problem of envisioning it, because in a hexagonal packaging, you've got 1 surrounded by 12. So then those 12 need to be either 6 positrons, 6 electrons, around 1 electron. And when you start trying to have them be alternating, you run into an issue.
I don't understand what you're talking about. I mean, if you take a bunch of ping pong balls and you form into a barrel, they will assume an organization, right?
I'm only trying to help you out here, because in a square configuration where they're sitting on top of each other, you can have it so that no positron is touching another positron. Because
well, I'm not saying that it does. See, this is the difference between ePola. See, ePola does that. They enforce a cubic structure on the EP pair so that at no point an electron and electron can be pointing at each other. Now, me personally, I think that space is actually a highly chaotic environment. That it's like a boiling keg of water. Right?
Well, move ahead.
So we're talking about basically an individual, say, proton, which consists of positron, electron, proton, electron, proton, squeezing its way through this ether C.
I'm not
squeezing. So okay, so the atoms are displacing the ether. They squeeze the ether out of the way, I suppose. All right, still doesn't. Sorry. Anyway, enough and such. It is what it is. So everybody's crazy. It's just I like Franklin. I like that he does try to break things down into the simplest mechanism possible. But it's just fundamentally somehow is attached to this idea that you need an ether, that ether is somehow the function. And I think it's just clear that the force is the function. That's where everything happens. And the forces are indestructible. And you can sort of get the idea that the energy, just follow the energy, just follow the things that are moving the speed of light. And you don't need an ether to do that. But anyway, oakley doke. Until the next time and such. I mean, any movement is movement. I mean, to expand and contract things, for things to be oscillating or doing whatever he thinks they're doing, they're still moving. So if you're going to create movement, just create movement so things can move all the way. Why not just move all the way? Why bother with this little movement when you just do one big movement? Yeah, so. Till the next time and such. Sorry, I'm just quite miserable. Pain. I mean, every spring this happens to me. It's just my jaw. Oh. It's weird. I mean, the whole biology thing, hormones, whatever goes on, just very strange. Some of it is so understood. Lots of things still need to be figured out. Anyway, what am I looking for? The off button. Ah, that's it.